This is a recast of the 4,500-word piece BERT, Bidirectional Encoder Representations from Transformers, from Schnippat AI. This article discusses natural language processing and the implications of BERT, a revolutionary neural network-based approach for various tasks and industries. Let's listen in.
In this piece, we're discussing natural language processing, or NLP. This field is focused on understanding and analyzing human language.
One of the biggest advancements in this field is BERT, or Bidirectional Encoder Representations from Transformers. This revolutionary neural network-based approach is all about capturing the meaning of entire sentences, paragraphs, and even long-form documents.
It's pretty amazing to think that BERT can understand the nuances and complexities of human language by processing both left and right contexts simultaneously. This makes it a valuable tool for many tasks, including sentiment analysis, question answering, and language translation.
As you can tell, BERT's success has led to the development of similar language models, such as GPT-2 and XLNet. This is continuing to expand natural language processing capabilities even further.
In terms of the history of natural language processing, the field really began to take off in the 1990s with the advent of statistical models and machine learning algorithms. This allowed computers to learn from large amounts of data and improve their language processing skills over time.
And then in 2018, BERT was released by Google AI Language. This was a significant development in terms of understanding the meaning of words in context. It was also a major milestone in the field of NLP that opened up many possibilities for applications in areas such as machine translation, text summarization, and chatbots.
So there you have it, a brief rundown on BERT and its implications for natural language processing.
Well, let's take a closer look. To start, BERT splits the input sentence into multiple tokens and takes in contextual information from the entire sentence. This means that it takes into account the entire sentence, not just the immediate context.
This is a major advantage over other models like EAL-EMO and OpenAI's GPT-1, which only consider the immediate context and often have difficulty understanding the meaning of the sentence.
Another thing to note is that BERT uses a transformer architecture, which consists of an encoder and a decoder. The encoder transforms the input into a hidden representation with self-attention mechanisms. The decoder then takes this hidden representation and generates the output sequence one token at a time, using both self-attention and cross-attention mechanisms.
So the transformer architecture allows for bidirectional processing of input sequences, which is key to BERT's success. And it also enables more accurate sentiment analysis, question answering, and even machine translation.
On top of that, BERT is also trained on large unlabeled data and can be fine-tuned on specific tasks like sentiment analysis or named entity recognition. This makes it very powerful and versatile for a range of language tasks.
Indeed, all in all, BERT is an impressive advancement in the field of natural language processing, and it's sure to open up new possibilities for businesses and organizations to leverage its power.
To further build on its success, BERT has shown great promise in tasks such as sentiment analysis, named entity recognition, and question answering. It's been able to accurately classify the sentiment of a given text and effectively identify and extract named entities from text. The impressive performance of BERT on these tasks has made it highly sought after by researchers, academics, and industry practitioners.
On the other hand, BERT also has some drawbacks. It requires a huge amount of data and computing resources to train. Furthermore, it's heavily dependent on the quality of the training data. Other criticisms of BERT is its performance in certain tasks, like those involving rare or out-of-vocabulary words.
Right. It's important to note, too, that there are concerns around the interpretability of BERT models and the potential of reinforcing existing social biases due to its use.
Despite these limitations and criticisms, BERT remains an incredibly powerful tool for natural language processing and a major milestone in the development of deep learning algorithms.
That's right. One of the advantages of BERT is its pre-training process, which is designed to capture the context of each word in a sentence by considering both its left and right context. This bidirectional approach allows BERT to effectively understand the meaning of words in a sentence, leading to more accurate predictions.
Additionally, BERT uses attention mechanisms to focus on relevant information and ignore irrelevant noise, further improving its efficiency. These improvements have been revolutionary for natural language processing.
Absolutely. To train BERT, however, you need access to high-performance computing and robust storage systems. Depending on the size of the model, the pre-training can take days or even weeks.
It's also important to consider computing resource requirements when deploying BERT models in production, as they require specialized hardware acceleration, such as GPU or TPU for maximum performance.
You also need to consider bias and ethical concerns when using BERT, as there is a risk that language models may reflect existing cultural and societal norms that perpetuate discrimination and prejudice.
That's why it's important to ensure that the models are trained on diverse datasets with strategies for detecting and addressing bias. Researchers and developers need to prioritize transparency and accountability by making their models open and accessible.
Yes, it's also important to consider the potential risks associated with BERT's language generation capabilities. Bias can be perpetuated in the generated language, and there is a risk that this technology could be used to create convincing fake news or propaganda.
In the future, researchers are hoping to build on the foundation laid by BERT and create even more powerful natural language processing models. This may involve leveraging multimodal inputs and incorporating external knowledge bases.
Additionally, BERT has been demonstrated to achieve impressive performance on natural language understanding tasks, such as question answering. This opens up a wide range of potential applications, such as in-machine translation systems, automated customer service, and chatbots.
The potential impact of BERT on industries such as healthcare, e-commerce, and finance is immense. In healthcare, BERT could assist in natural language processing of medical documents, enabling doctors to identify patterns and make accurate diagnoses. For e-commerce, BERT allows for more personalized search results, improving customer experience and increasing sales. In finance, BERT could be used to monitor financial news in real time, making it easier to detect potential risks.
Right. And the integration of BERT with other AI technologies also brings about exciting advancements. For example, it could be used in conjunction with image and speech recognition to create more comprehensive AI systems.
Exactly. But of course, all this potential doesn't come without risks. It's important to reflect on the ethical implications of this technology. We must be mindful that bias can be perpetuated in generated language and that there is a risk that it could be used to create convincing fake news or propaganda.
So how do we ensure that we're using this technology responsibly?
Well, it starts with being aware of the limitations and potential harms associated with the use of such language models. We should also strive to develop more diverse training data and increase transparency in model design and decision-making.
Absolutely, and in general, it's important for us to remain vigilant about the ethical implications of BERT and strive to achieve responsible and inclusive applications of this technology.